Welcome to qnawire.
So we're going to be using the divergence theorem for this section. And the divergence theorem states that the double integral of f ds is equal to the triple integral of the divergence of f dv. With all that in mind, let's calculate the divergence of f, which is the partial derivative of z with respect to x. And we know that the partial derivative of z with respect to x is 0. And this is all coming from what we've been given. So it's partial derivative of p with respect to x plus the partial derivative of q with respect to x plus the partial derivative of r with respect to x. So it's going to be 0 plus the partial derivative of q with respect to y, which will just be 1, plus the partial derivative of r with respect to z, which will just be x. So that'll equal 1 plus x as our divergence of f. Then we want to choose the order of integration to be dz, dy, dx. So we're going to have to find limits for each one. Looking at what we have for the boundary, we have that z has a lower boundary of 0 and it has an upper boundary, which is the surface of the tetrahedron. So when we solve for z, what we'll end up getting is c times 1 minus x over a minus y over b. So when it comes to us calculating this integral, we'll bring this right here. We know that the divergence of f is going to be 1 plus x dv, and we chose it to be dz, dy, dx. We said that the lower bound for x is 0, and the upper bound for x is c times 1 minus x over a minus y over b. And then for y, we see that the lower boundary for that is going to be 0, and the upper boundary for that will be b times 1 minus x over a. Upper bound for the y limit. And then for x, we see is just from 0 to a. So we do all this. When we solve the first integral, we end up getting c times 1 plus x times 1 minus x over a minus y over b. And then we take the second integral that we have, and that comes down to, on the outside we have abc over 2, and then on the inside we have u squared plus au squared minus au cubed, and that is a result of substitution, so this becomes 1. And then once we solve this right here, we end up getting 4 plus a. So our final result that we'll end up having is going to be this right here, abc over 24 times 4 plus a.